All right, folks. So remember on paper two, this is the extended answer paper. And so be sure that you read all of the questions carefully before you begin. You've got roughly 90 seconds per mark on these things. So 2 marks, that's roughly 3 minutes for this question. Just keep that in the back of your mind. All right, so the first thing we're going to do is read it. Phosphorus is an element, essential part of the biological molecules involved in both respiration and photosynthesis. Okay, fantastic, but really irrelevant. There's nothing actionable there. Now we have the command term, draw the orbital diagram of the phosphorus atom in the ground state by adding, filling, and labeling the orbitals. Use section 7 of the data booklet. Well, section 7 of the data booklet, of course, is the periodic table. So I have taken a piece of the periodic table here. So we are looking at phosphorus, right? That's our target right there. Actually, let's not do that. Let's do this instead. So there's phosphorus right there. There's our target. Now, it said you want to do an orbital diagram, and it also said ground state. So ground state means that we are looking only at that number of electrons, okay? So 15 electrons. So we have 15 electrons to add. They've started you off on an orbital diagram, 1s, 2s, all right? So 1s, of course, is going to have 2 electrons in it to fill it. That brings us to here. So this is the 1s, yeah? 2s is going to have 2 electrons to fill it. That brings us to here. So that's the 2s. The next set of orbitals to be filled is the 2p, because that's the geography of the periodic table. All of these, there are 6 of them, as you can see here. Remember that they are degenerate. Okay, they all have the same energy. Okay, so that's called degenerate. Use the wrong color there. I like to use this color for notes that don't show up in the answers, right? So degenerate equals same energy. Then of course you have to label it, 2p, and then you put your electrons in. Now, just in case, okay, we're going to go in 1, 2, 3, singly and parallel until forced to pair. That's Hund's rule. 4, 5, 6. And that brings us to a total of 10, which brings us to here. Now, when we go into the third set of orbitals, I'm going to do them in a different color here. That's going to be the 3s and the 3p. But remember, we're going to have to stop at phosphorus, so we only need 5 more electrons. So our 3s is going to be a single orbital with 2 electrons in it. And then our 3p will also be degenerate. Need 5. They go in 1, 2, 3, 4. Actually, excuse me, I was wrong. They only go, apologies, 1, 2, 3 in the 3p. So you should have 3 unpaired electrons at the top. Now this goes back to structure 1.3.5 if you want to look it up in your curriculum syllabus. Now it's got 2 marks, all right? So let's see what the marks were from the IB. Okay, so there is our diagram, right? We have to have correct labels. So in other words, if you have these on there, you would get that marked even if this part was wrong. And you have to have the correct electron configuration, okay? And that means those 3 are singly and parallel. Now, remember, if you get 1 out of the 2, all is not lost. 50%, On average, you're going to end up with a 4.